Welcome to PMDC's online lecture room. The topic of this video lecture is Magnetic Behavior of Transition Elements, selected from Textbook of Chemistry for Grade 12, Chapter 14, D and F Block Elements. Questions from this topic are taken in previous bicep papers. For example, explain the characteristic properties of transition elements. This question was included in the bicep paper of 2006, 2013 and 2014. Now if you have watched the previous video, we have discussed the first property, that was the catalytic properties of transition elements, and now we are going to discuss the second one, which is magnetic property of transition elements. To understand magnetic behavior of transition elements, we will go through magnetic behavior, types of magnetic behavior, examples, MCQs, and at the end, an assignment. The picture you are looking at is of a magnet, and what a magnet does, it attracts some substances towards it, but it also repels a few substances away from it. This behavior of a magnet is called magnetic behavior, and it is defined as when a substance is exposed to magnetic field, it responds in several ways, which are called magnetic behavior or magnetic property. Types of magnetic behavior. Magnetic behavior is of three types. First, paramagnetism. Second, ferromagnetism. Third, diamagnetism. So let's try to understand each. Paramagnetism. It is defined as the substances which are slightly attracted by a strong magnetic field are called paramagnetic substances, and the phenomena is called paramagnetism. The reason for paramagnetism is the presence of one or more unpaired electrons in their orbitals. Electron in an atom revolves around the nucleus and also spins on its own axis, whether in clockwise direction or in anti-clockwise direction. Electron is a negatively charged particle, and any moving charge produces its own magnetic field. Carefully observe this electron. It is not only revolving around the nucleus but is also spinning on its own axis. As electron is a charged particle, moving electron produces its own magnetic field. Due to the magnetic field produced by the unpaired electron, the substance acts as a magnet and is attracted by the external magnetic field, thus behaving as paramagnetic. So paramagnetism is basically due to the unpaired electrons. Main point or the key concept is greater the number of unpaired electrons, greater is the attraction towards the magnet. Now let's list some of the paramagnetic elements of the periodic table, like oxygen, lithium, sodium, aluminium, platinum. Now we will elaborate the paramagnetic behavior of the first transition series from scandium to copper. If we look at the electronic configuration of first three members, scandium, titanium and vanadium, it shows that scandium has one unpaired electron in 3d orbital, titanium has two unpaired electrons in 3d orbital, and vanadium has three unpaired electrons in the 3d orbital. So due to the presence of these unpaired electrons, they are attracted towards magnet and are called paramagnetic substances. The second type of magnetic behavior is ferromagnetism, which is an extreme case of paramagnetism. It is defined as the substances which are strongly attracted by the strong magnetic field are called ferromagnetic substances, and the phenomena is called ferromagnetism. The reason for the ferromagnetism is the presence of large number of unpaired electrons in the orbitals. Remember the key point? Greater the number of unpaired electrons, greater is the attraction towards the magnet. If we look at the electronic configuration of the next three members, that is chromium, manganese and iron, it shows that chromium has 5 unpaired electrons in the 3d orbital, manganese has 5 unpaired electrons in the 3d orbitals, and iron has 4 unpaired electrons in the 3d orbital. As the number of unpaired electrons has increased, their attraction towards the magnet also increases, and this extreme attraction towards the magnet is called ferromagnetic behavior. Iron, due to the presence of large number of unpaired electrons, is so strongly attracted towards the magnet that the particles made of iron even stick to the magnet. Manganese, due to the presence of 5 unpaired electrons in the 3d orbital, is strongly attracted towards the magnet and is also ferromagnetic substance. Compounds and ions of transition elements also show ferromagnetism. For example, manganese +2 ion, present in manganese 2 chloride. In +2 oxidation state, manganese has 5 unpaired electrons in the 3d orbital. Similarly, iron +3, present in iron 3 oxide, has 5 unpaired electrons in the 3d orbital. As the number of electrons in the 3d orbitals is greater, so the paramagnetic behavior is strongest for iron +3 and manganese +2, and they are called as ferromagnetic substances. Students, note down this point that the paramagnetic behavior is strongest for iron +3 and manganese +2, and iron +3 and manganese +2 are ferromagnetic in nature. This point is also very important for the MCQs. The third type of magnetic behavior is diamagnetism. It is defined as the substances which are slightly repelled by the magnetic field are called diamagnetic substances, and the phenomena is called diamagnetism. The reason for the diamagnetic behavior is the pairing up of the electrons. Electrons are paired up in their orbitals, and the magnetic field of the oppositely spinning electrons cancels out each other. Thus the substances become diamagnetic. If we look at the electronic configuration of the last member of the first transition series, that is copper, the electronic configuration shows that copper has all the paired electrons in the 3d orbitals. The one is spinning in the clockwise direction, the other in the anti-clockwise direction, and thus they cancel out the magnetic field of each other. So when we place a copper wire in magnetic field, it is slightly repelled by the magnetic field, showing that copper metal is diamagnetic in nature. This blue salt you often use in your lab is copper sulfate. In copper sulfate, copper ion is in +2 oxidation state, and copper +2 ion has 1 unpaired electron in its orbital. Now think out yourself whether it is paramagnetic, diamagnetic or ferromagnetic, and here is the hint. Now let's try out some MCQs. The first MCQ is from ETA 2009, and it says that oxygen molecule has 2 unpaired electrons. It is therefore ferromagnetic, diamagnetic, electromagnetic or paramagnetic. Now oxygen molecule has 2 unpaired electrons, so that's why it is paramagnetic. Now let's do the second one. Which of the following is a strong magnet? Diamagnetic material, paramagnetic material, antiferromagnetic material or ferromagnetic material? And yes, we know that ferromagnetic materials behave as a tiny magnet. So the correct option is ferromagnetic materials. Now let's quickly conclude whatever we have discussed. Magnetic behavior is of 3 types. First, paramagnetism. The substances which are weakly attracted by the strong magnetic field due to the presence of unpaired electrons are called paramagnetic substances, and the phenomena is called paramagnetism. Second, ferromagnetism. The substances which are strongly attracted by the magnetic field due to the presence of large number of unpaired electrons are called ferromagnetic substances, and the phenomena is called ferromagnetism. and it is the extreme case of paramagnetism. Third, diamagnetism. The substances which are slightly repelled by the magnetic field due to the presence of paired electrons are called diamagnetic substances, and the phenomena is called diamagnetism. In first transition series, aka 3D series, at the beginning the substances are paramagnetic. The paramagnetic behavior increases, reaches to maximum, that is ferromagnetism, at manganese and iron, and then decreases again to the diamagnetic behavior of copper and zinc. Now by the end there is an assignment consisting of 2 questions. First one, what is paramagnetism? Second, discuss the ferromagnetic behavior of iron.